archaeologist, I'm interested in questions about our human past. Not lost treasures or chronologies of kings and queens, or what life was like for people living in ancient palaces. I want to know what life was like for common people, for the farmers that grew staple crops, for the shepherds that herded animals that were sacrificed in rituals, and for people who put food on the table in a family household. Understanding how normal people lived is key to understanding how societies functioned and evolved. In my work, I use techniques that archaeologists have borrowed from the natural sciences, chemistry, biochemistry, geology, to analyze the materials that we have uncovered at archaeological sites at a molecular level. This enables us to study what people in the past ate, how they transformed their environments, and how they moved across large and small distances. Today, I want to share with you some of the work that I have done and reflect on some of the lessons that I have learned from the past. I have been lucky to collaborate with a number of colleagues in different countries and environmental locations. Through these international collaborations, we studied how prehistoric farmers in Greece grew domestic crops and raised domestic animals, and how that affected their living spaces and village organization. In southern Levant, we examined the diets and the movements of animals in the Negev desert during the Byzantine period to see if any climatic shifts led to the abandonment of the settlements and the eventual withdrawal of the Byzantine Empire from this region. Right now, I'm working at the Laboratory for the Analysis of Early Food Webs at Washington University in St. Louis, where we investigate how crops and animals that were first domesticated in Southwestern Asia and those that were domesticated in Eastern Asia spread in both directions across the continent, and what decisions people made to adapt them into agricultural and culinary systems in varying microclimates. These research projects might seem a bit disconnected. They're from different geographical regions and from different points in time. But there's one thing that resonates through all of them, beyond the knowledge about ancient subsistence economies or climate fluctuations. And that is the idea of connectivity. Whether we're looking at Greece 7,000 years ago or the Byzantine Empire 1,600 years ago, connections that people established between communities through exchange of ideas, artistic styles, animals, or objects played a key role in the development of their traditions. People's cultures did not develop in isolation. So let's explore this in more detail. The techniques that I use in my work measure the ratios of elemental isotopes, or different versions of the same element at different masses. These ratios for materials like bone and teeth hold very specific information about the life of these individuals. Bones remodel themselves throughout our lives, and the atoms and the molecules from the food that we eat go directly into building this new tissue. So by measuring the isotopic signatures in archaeological bone collagen, for example, we can detect the input of food items with very distinct isotopic signatures, which result from plants using different photosynthetic pathways, growing in different types of soils, and also from where the food item is located on the food chain. At the site of Makrialos in northern Greece, we learned that more than 7,000 years ago, people hosted a series of very large feasts, which brought together communities from the wider reaches of the region, and where large amounts of meat, we're talking tens of tons of beef, lamb, and goat meat, were consumed within a few months at most. I analyzed the isotopic compositions of the teeth of some of the animals consumed in these feasts to see if they were all raised in the local landscape or if they were brought to the feasts from more distant parts of the region. For each tooth, I drilled a sequence of samples from the top of the crown down to the root. Second molars of herbivores form over a period of 12 to 18 months and mineralize in this same direction. So a sequence of isotopic values told me which part of the tooth formed in the summer and which part formed in the winter of their first year of life. I then used this information to drill the tooth again and targeted the summer and the winter portion to get a strontium isotopic ratio, which can be used as a geological fingerprinting tool. The results showed that most of the animals that I analyzed were raised in the local coastal environment, but some of them were born at least 35 kilometers away in areas with older geology. And because they were killed after their teeth finished formation, they were actually brought over before the feast and integrated into the local herds. This signifies a high degree of communication and planning between the communities to make these regional feasts happen. At the Byzantine sites that we studied in the Negev desert, we learned that people built large agricultural installations in the desert landscape. These included water collection areas that were built in wadis or dry riverbeds, and drainage channels that weave their way through the hilly topography. These systems enabled inhabitants of the desert to collect enough rainwater to grow fruit trees, cereals, and grapes that were turned into wine, which was exported across the Mediterranean. Trade networks that ran through this region eventually connected people from the port town of Gaza, just north of the Negev, to the coast of northern Italy. The isotopic work that I carried out looked at the composition and the seasonal patterns of animal diets in order to investigate where the animals were grazing and whether nomadic pastoralists herded the animals out of the Negev on a seasonal schedule, like Bedouin pastoralists did in the early 20th century. They moved from the Negev as far as 200 kilometers north during the drought year. Our findings show that the animals moved, but they stayed within the desert landscape and ate vegetation that was constrained to the drainage channels. And towards the end of the Byzantine period, they did not experience a dramatic climatic shift, which would have forced them out of this region. What happened instead is the trade networks collapsed and the connectivity with this region was severed. My work at the moment examines the movement of crops and animals that were initially domesticated in southwestern Asia more than 10,000 years ago and became major food items in eastern China by 4,000 years ago. These include wheat, barley, sheep, and cattle. The Heshi corridor in the Gansu province of China provides an access route through which these domesticates travel to get to northeastern China. The western part of the corridor is hot and dry. The eastern part is influenced by the East Asian summer monsoon and is therefore wetter and more suitable for farming. Beyond mapping where the crops and the animals occurred and at what time, we're interested in the people and how they actually went about managing the animals across this diverse landscape, and what roles the crops and the animals played in the people's eating habits. To answer these questions, we're analyzing the stable isotopic values of bone collagen. This enables us to identify specific dietary patterns of the humans as well as the animals. Did the wheat and barley become staple crops soon after they were introduced into this region? Were the animals grazed on the available pastures, or were they kept in stalls and fed a diet of agricultural products? How did the different environmental conditions lead to local variations in management patterns? All of these questions enable us to study the lives of the people and the decisions they made as they adapted their existing farming strategies and culinary traditions to these exotic domesticates. All these societies that we looked at changed over a period of time, whether it was over several millennia or a few centuries. They changed by adopting exotic crops, new technologies, or trading with other communities. And all of these interactions were made possible by communication and exchange of ideas. The societies developed their own traditions, which were shaped by their local environments and the people that maintained them. But the traditions themselves became an archive of past events that connected people across larger and smaller distances. In prehistoric Greece, communities were connected in a network of trade. We see similarities in objects, and we see raw materials like obsidian stone in places where they can't be found locally. But beyond that, the people invested a lot of effort into having people meet face to face during large feasting events. The Negev Desert was settled several times in history and prehistory, in the Iron Age, the Bronze Age, but it reached its population and economic peak during the Byzantine period, all thanks to connectivity. Across prehistoric Eurasia, people created a food globalization network that allowed them to adapt new crops and animals to their long-standing farming strategies and culinary traditions. Cultural heritage and local traditions are important. They are what give our lives meaning, but isolating them from the world doesn't let them thrive. Allowing them to evolve and change lets them thrive. Our world, the environment, and the human populations inside it will change regardless of whether we like it or not, and the way forward is to enable cultures to create local diversities, to celebrate local diversities while preserving connectivity.